Number 92, you do have a calculator in case you are unable to do subtraction. But number 92, this is a tough one. They're telling you that you have a function that is twice differentiable. They have to say that. That allows you to know that you have continuity, differentiability, and the first derivative has continuity and differentiability because both of those are needed. Because you're actually doing a mean value theorem too deep. Believe it or not, that's what this is. So they're asking you which of the following could be the graph of f double prime. And all you have is information about particular y values of f of x. And if all you do is kind of plot these, approxiplot these points, well, not approxiplot, but plot these points, it's not going to be enough. You're going to be like still very, very confused. So here's the issue. I went through and did a too deep difference on this. So you can see that from 1 to 3, I'm adding 2. From 3 to 4, I'm adding 1. That was a 1. Subtracting 3, adding 3. By the way, if my arithmetic is wrong with any of these, please tell me. Then I went into the second deep difference. From positive 2 to positive 1, you have to subtract 1. Then you have to subtract 4. Then add nothing, and then add 6. Now, when you are in a one deep mean value theorem, is everyone with me? Is everyone with me? I see the fading out going on in the classroom, so I'm assuming online it's even worse. Okay. Mean value theorem says that between this, listen carefully, it's been a while since you've had mean value theorem. Between x equals 1 and 2, you definitely have a slope of 2 somewhere in there. Understand that this is what the mean value theorem is telling us. The mean value theorem is telling us that somewhere between x equals 2 and 3, we will have a slope of a positive 1 somewhere in there. Now, that's going to take you too long. So I'm going to now take you into the next depth because we are looking at f double prime. With f double prime, this negative 1 is coming from looking between x equals 1 and x equals 3 of these two deep. Do you see what I'm showing you? Take a good look at that, because this is what you need to realize. When you go into a too deep mean value theorem, then you are looking at somewhere between x equals 1 and x equals 3, you will have a second derivative of negative 1. So with that one statement, I'm going to go through and look at these. Between 1 and 3, do I have a negative 1 value? No. Between 1 and 3, do I have a negative value? Yes, I do. Not much, but I do. Somewhere between 1 and 3, do we have a negative value? Yeah, we do. Okay. Somewhere between 1 and 3, do we have a negative value? Yes. Somewhere between somewhere between 1 and 3, do we have a negative value? Yes. So only the first one was cast out on that. Now, we can keep going with this, but I'm going to turn you over to this one. That's somewhere between 3 and 5. And let me point out that that 0 came from a mean value theorem that occurred between 3 to 4 and 4 to 5. Somewhere between 3 and 5, your second derivative is equal to 0. So I'm looking at which of these graphs have a second derivative value equal to 0 between 3 and 5. And the answer here is no. The answer here is no. The answer here is yes. And the answer here is no. And if I went back up to letter A, that one had a yes for this. So, you know, if you sit here and work left to right, it may take a while. 0 often is a quick one to look for. But, you know, if you're dealing with a table and you're having to actually look at fine details like this, I can't tell you what order to go in. It's not necessarily going to work out quickly, but it might be that one of these goes really quick. But which one? Don't know. But just take another good look at this later and work this out yourself. Actually do a fresh problem later. See if you can come up with this same idea and make sure that you can see why we're looking at from x equals 1 to 3, I must have a second derivative of -1. From 2 to 4, I must have a second derivative value of -4. From 3 to 5, I must have 0. From 4 to 6, I must have a +6. And the issue is more about negatives, positives, and 0. Take a look at this again at another time. And end the recording.